All right, strap in, everyone. Today we are going deep on quantum computing.
Yeah.
Some really interesting stuff coming out of INRS. They've built this new photonic lattice system.
Right.
And it could revolutionize how we think about quantum computers.
Wow.
Even things like super secure communication. We've got a lot to unpack here.
Yeah.
But we'll break it down,
Okay.
make it easy to understand.
I think it'll be pretty clear.
And what it could all mean, for the average person.
Yeah, absolutely.
Okay, let's start with the basics.
Sure.
What exactly are a synthetic photonic lattice?
Well, imagine a grid, okay?
Okay.
Like a really, really tiny network of fiber optic cables and light particles, photons, move along these very specific paths in this structure. The synthetic part just means we're creating these lattices artificially.
Okay.
Which is amazing because it gives us really precise control over how the light behaves.
So we're basically building like tiny little light highways.
That's a great way to put it.
I like that. But how does this connect to quantum computing?
Yeah.
Specifically, this idea of quantum walks that I kept seeing in the research.
Okay, so think of it this way.
Sure.
Normally, if you want to walk from, say, point A to point B,
Right.
you pick one path, right?
Yeah.
But in the quantum world, it's different. A photon can kind of take every single path at the same time.
Whoa.
It's exploring all the possible routes simultaneously.
Yeah.
That's a quantum walk.
That's a quantum walk.
Yeah, and that's a big part of why quantum computing is so powerful.
I can start to see how that would lead to, like, insane processing power.
Oh, yeah.
But controlling these quantum walks seems really, really complex.
Very much so.
How did the researchers at INRS even do that?
So that's where their breakthrough comes in. What they did was they created a temporal synthetic photonic lattice.
Okay, instead of controlling the photons in space, they're manipulating them as they move through time.
Exactly. It's like a whole other dimension of control over light.
Okay, so we're not just talking about manipulating space, but manipulating time.
That's exactly it.
Whoa, that's crazy.
Yeah.
What makes that temporal approach so much better?
Well, for one, it could be a lot more efficient and practical than the older methods.
Okay.
But here's the other thing that is super exciting. It might work with our existing telecommunications infrastructure.
Wait, so you're saying we could integrate this with the fiber optic networks we already have?
Potentially, yes.
That would be huge. Tell me more about why that matters so much.
I mean, think about it. We wouldn't have to build entirely new systems from scratch.
Yeah.
We could just upgrade what we already have.
Right.
That makes this way more realistic,
Totally.
Getting this out there widely.
Yeah, it would speed things up a lot instead of ripping and replacing everything.
Exactly.
Okay, let's shift gears a bit.
Sure.
Talk about what we could actually do with this.
Yeah.
The research mentioned quantum computing and secure communication.
Right.
Both huge EE implications.
Totally.
Break it down for me. Like, how could this actually change things?
Well, let's start with quantum computing.
Okay.
Imagine being able to run these super complex simulations to design like completely new materials. Or how about developing medicine that's tailored to your specific genes?
Oh, wow.
Those are things that regular computers would take forever to solve.
Yeah.
But with quantum computers,
Yeah.
powered by these photonic lattices,
Uh-huh.
we could find solutions in years or even months.
That's incredible. It feels like we're on the verge of
It is pretty amazing.
unlocking this whole new level of computing power.
Yeah.
Okay, what about secure communication?
So that's where things get really interesting with quantum mechanics.
Okay.
We can use this thing called quantum entanglement
Right.
to create communication channels that are basically unhackable.
Really?
It'd be like having a conversation where only you and the other person have the key to understand it.
So no more data breaches.
Theoretically, no.
No more hackers stealing sensitive info.
It could be a game changer for security.
What kind of impact would this have on things like online banking or government communications?
I mean, it could completely change how we think about sensitive data.
Yeah.
Imagine a world where online transactions are totally immune to cyber attacks, or where governments can be 100% certain that their messages stay confidential.
Yeah.
It could revolutionize the digital landscape.
It's mind-blowing how something like how light behaves could change our digital lives so much.
Yeah, it all comes back to those quantum walks.
Right.
That ability of a photon to be in multiple places at once.
It's a lot to wrap your head around.
It is.
But it's also super exciting.
Yeah.
I'm sure there are still some challenges, though, right?
Oh, absolutely.
What are researchers still working on in this field?
Well, this research is a big step forward,
Huh?
but we're still early on
Okay.
scaling up this technology and making it even more efficient
Right.
and really exploring all the possible applications.
Yeah.
Those are all areas where there's a lot of ongoing research.
Like what specifically?
Well, for example, one of the big hurdles is figuring out how to keep those quantum states stable inside these lattices for a long enough time.
So there's still a lot of work to do.
Definitely.
What does that mean for people who are interested in this field?
It means there's tons of opportunity out there.
Oh, yeah.
As the research continues,
Uh-huh.
we're going to need talented engineers,
Oh.
physicists,
Yeah.
computer scientists
Yeah.
to really push the boundaries.
Yeah, what I always like to point out,
Yeah.
these deep dives aren't just about understanding this complex stuff.
Right,
It's
right.
also about seeing the amazing opportunities that are out there.
Yeah, for sure.
Now, before we move on,
Yep.
I want to go back to something you said earlier
Okay.
about unhackable communication.
Uh-huh.
Doesn't that bring up some ethical questions too?
Oh, absolutely.
Yeah.
Yeah, I mean, think about it. If all our online activity was totally private,
Yeah.
how would that affect things like law enforcement?
Hmm.
You know, being able to investigate crime.
That's a good point. Police and stuff often rely on being able to look at communications
Right.
to find evidence and, stop bad stuff from happening.
Exactly. And unbreakable encryption
Yeah.
would make their job a lot harder.
It's like a tough balance, isn't it?
Yeah.
We want everyone to be safe and have privacy,
Right.
but we don't want to make it easier for criminals to do their thing.
Exactly.
Are there any ideas out there for how to deal with that?
Well, there's definitely a lot of discussion about it.
Yeah.
Some people talk about things like backdoors or key escrow systems
Uh-huh.
where you'd have a way to get access to that encrypted data,
Okay.
but only in specific situations.
Right.
But those ideas are controversial,
Yeah.
because they could actually make the whole system less secure.
Yeah. It sounds like finding the right solution is going to take a lot of careful thought and input from a lot of different people.
Yeah. Policymakers and privacy advocates,
Right.
tech experts.
Yeah. It's not just a tech problem.
No, it's not.
It's a societal one.
For sure.
We need to really talk about what this tech could mean for us
We do.
and work together to find solutions that make sense for everyone.
Absolutely. Technology should serve us,
Yeah,
not the other way around.
I like that. Well, this has been an amazing deep dive.
Yeah, it has.
Not only have we learned about the potential of this new photonic lattice technology,
Right.
but we've also uncovered some really important questions about
Yeah.
privacy, security, and, the role of technology in our lives.
It really makes you think.
It does. And remember, this is just one example of all the incredible things happening in quantum technology.
It's an exciting time.
It really is. Who knows what other crazy discoveries are out there just waiting to be made?
The possibilities are endless.
Well said to all our listeners out there.
Yeah.
Keep exploring
Keep asking questions.
and keep pushing the boundaries of knowledge.
That's how we move forward.
The future is full of possibilities,
It is.
especially when we embrace the power of science and innovation.
Absolutely. Until next time, everyone.
Stay curious.